Intro Midnight, B-roll, fast cuts of news headlines, PyPI breach, developers exposed, API key leak. Look, could a Python package really leak your API keys to hackers? I'm about to find out, Lit. By the end of this video, you'll know exactly how the Litellm situation played out and how to protect yourself. Screen recording, opening a terminal, showing a fresh Python virtual environment. Timestamp 0:30. The bet, PyPI, Litellm, and the experiment. Let's make this real. Today, I'm testing a massive claim that just by installing or updating a single package, Litellm from PyPI, over 100,000 developers might have exposed their API keys. If you work with OpenAI, Cohere, or even Hugging Face, you should care. So here's the bet. I'll try installing different versions of Litellm, old, patched, and possibly effective. I'll monitor my network and file system log to see if any of my API keys get touched, uploaded, or sent where they should. Real tools, real results, no flop. Timestamp 1:30. The rules. What I'm really testing. Let's be ruthless about the process.
Rule 1. I'm only using genuine environments. No test rigs that hide results. I'll use packet monitoring tools like Wireshark and API monitoring add-ons. If data leaves my system, I'll catch it. Rule 2. I'll generate real dummy API keys. Nothing fake. Using my OpenAI sandbox account and dummy Hugging Face tokens. Why? Because attackers don't care if your key is for demo only. They just want any credential. Rule 3. I'll check package versions and compare both the pre and post-patch look. If there's a leak, I want to see when it happens. Success. If an API key appears in a suspicious outbound request, file, or log, that's a problem. If nothing happens, even better, and we'll know what's really going on. Timestamp 2:15. 3. Day by day / test by test. Show the process. Test 1. Installing the latest Litellm from PyPI as of March 2026. Screen recording. Pip install Litellm. Opening Wireshark. We're running a fresh install. Network's clean. No connections yet. Now, let's load in a config file with dummy API keys. Screen recording. Opening config.yam. Showing dummy open __ key. Cohere __ key. Now I'll import and use Litellm as a normal developer would. No fancy scripts. Save file. Run basic test. Screen recording. Running Python test _Litellm.py. Opening Wireshark side by side. Did anything weird happen? For this version, no outbound traffic to unfamiliar domains. Hugging Face. OpenAI domains. Normal. Nothing unexpected. B-roll. Code running. Hands typing. Timestamps. Test 2. Installing Little version 1.27.0 from February 2026. The one flag and advisories. Screen recording. Pip install Litellm == 1.27.0. Confirming version. File directory. Running same dummy script. Watching Wireshark. This time, right as the script imports the config, I see an outbound post request. But it's to a logging server clearly listed in Litellm's docs, not a sketchy domain. Let's inspect the payload. Screen recording. Opening Wireshark captured packet. Decoding HTTP bot. Here's the twist. There are API keys in the payload, sent in clear text. Let's go to a log endpoint that, according to advisory notes, was previously exposed due to a misconfigured environment variable. Devs, this endpoint was supposed to be private, but for at least 3 weeks, it was. Test 3. Installing the patched Litellm version 1.28.1 released after the breach was exposed. Screen recording. Pip install Litellm == 1.28.1. Repeat process, side-by-side logs, and Wireshark. All looks clean. No API keys and outgoing packets. Only the legitimate API requests. This is what we expect. Good job, patch team. Let's do a final check. What if I purposely misconfig? I add debug mode, verbose logging, and run again, simulating a messy real-world setup. Screen recording. Changing config. Adding debug = 1. Rerunning script. Nothing extra sent. Looks like they finally fixed that log forward. But if you were on an older version during the breach window, your keys could have been snatched. Timestamp 7 o'clock. Or the surprising part, what actually caught me off guard. Here's what surprised me. Usually, when packages have breaches, you expect a sudden spike in questionable network traffic. With Litellm, the bad behavior was incredibly subtle. It only triggered for users who enabled certain logging modes or custom environments. That's why it sat undetected for so long. Also, ChatGPT and Claude didn't recognize the breach at first when I asked them early in March. Only after the official advisory did their results update. Shows you can't count on AI to catch breaking security news in real time. Screen recording. ChatGPT versus Claude queer. Was Litellm compromised on PyPI? The real kicker. Even running in Docker, Cloud Runners, or Collab, anywhere you install dependencies on the fly. The old version would leak keys. No questions. This isn't just about your laptop. It's about CI and cloud too. Timestamp 8 o'clock. 5. Final results. The numbers, screenshots, proof. Let's lay it out. Out of 4 test runs on the flagged Little version, API keys were transmitted on 2, specifically when a logging endpoint was left at its default. No warning, no confirmation. In one test, the endpoint was still public for 4 days after the patch drop. Screen recording. Screenshots of packet logs. Timestamps. Visible API key strings. Redacted for safety. The up-to-date version. 0 transmissions. That matches the vendor's claims. How big was the window? According to public PyPI logs, more than 100,000 installs happened during that 3-week breach. But here's the thing. The log server was indexed briefly carefully by search engines. That means credential dumps could be sitting out there, not just in private hacker hands. Don't assume you're safe just because you patched late. Timestamp, 9 o'clock. 6. Honest verdict. Should you be worried? Worth it or skip? Here's my take after actual packet captures and AI-powered checks. First, if you installed or updated Little between February and March 2026, rotate your API keys today.
Don't wait. Assume they were compromised, especially if you use CI pipelines, Collab, or Docker autoscripts. Second, is PyPI still worth trusting? Yes, but only with proper security. Freeze dependency versions, monitor advisories, and always use secret scanning tools. There's no one and done in code security. And yes, even top developers got caught. Third, AI like ChatGPT and Claude can help interpret advisories, but you still need a human eye and packet logs for bleeding-edge threats. My honest verdict, Litellm is worth using if and only if you keep it up to date and run secrets, scanning regularly. PyPI's breach windows are rare, but absolutely real. Don't sleep on it. If you value experiments like this, subscribe here for more real-world finance and AI testing. Next up, I'm testing AI agents to hunt for leaked keys in your own code base. You want to see the results? Screen recording, channel subscribe animation, preview clip of detecting leaked keys with AI tools. Thanks for watching. Don't let someone else steal your API budget or your data. See you in the next one. Finance AI Pro out.